In last class we discussed about the unijunction transistor. In that we studied the construction, working principle of UJT. Then after we discussed the characteristics of UJT along with applications of UJT. Today we will discuss one of the special purpose electronic device. It is a triac. It is one of the important power electronic device like SCR. This triac stands for triode for alternating current or triode for AC switch. It is also like silicon control rectifier device. This triac is used to control the AC power, and it is a bidirectional switch because this triac can conduct in both the directions. That means for the positive half cycle and negative half cycle of the supply. The triac is a 3-terminal semiconductor switching device which can control the AC current in a load, or a triac can be formed by connecting the two equivalent SCRs in inverse parallel to one another, and the gates of the two SCRs are connected together to form a single gate. The three terminals are named as MT1, MT2 or anode 1, anode 2, and third terminal is named as gate. We can observe the forming of triac by using the two SCRs. So here two SCRs are connected in the anti-parallel to each other. In the two SCRs, the two gates of the two SCRs are connected, the terminal named as gate, and anode and cathode of each SCR is connected, and the terminal named as one is MT1, another one is MT2. Otherwise, we can say it is anode 1 and anode 2. So it is looking like silicon control rectifier, but in the silicon control rectifier we are having the three terminals named as anode, cathode, gate, but here we don't have anode and cathode separately. Here we are having two terminals named as anode 1 and anode 2. We don't have cathode. Otherwise, you can say it is MT1, MT2. You can observe the diagram in this slide. Yes. So we are having P and PN, P and PN, two silicon control rectifiers that are connected in the anti-parallel. So P and N-type material of two SCRs are connected as MT2, and N and P-type materials are connected to the MT1. The gates of two SCRs are connected. It is named as gate terminal. Yes, you can observe the circuit symbol of triac and internal structure of this triac in this slide. principle of track. So a track consists basically two SES which are in anti-parallel. Yes, we can say the working principle of track is similar to the serial control rectifier, but here the main difference between the silicon control rectifier and track is the silicon control rectifier is unidirectional. It will work in only for bias, but coming to the track, it will work for the positive half cycle and negative half cycle, because here we are having the two SES in the antiparallel construction. Yes. So the track will act as a switch for the both the directions. Yes. So triac can conduct if the voltage is equal to the breakdown voltage, but the most preferred way of turning on triac is providing a gate pulse, either a positive or negative pulse. So in serial control rectifier, SCR is also connected if the voltage is applied to the greater than the breakdown voltage, then SCR will turn on. Otherwise, when you are supplying the sufficient gate pulse to the SCR, then signal to rectifier will turn on. Like SCR, here also this triac can be conduct if the voltage is equals to the breakdown voltage, or by supplying the gate pulse to the track circuit. So here the gate pulse may be a positive or negative. Yes. So from that, the triac operates in the different types of modes. So the modes of operation of triac is given below. Here we are having three terminals, MT1, MT2 and gate terminal. In first condition, when MTT is positive with respect to the MT1, with gate is positive. In second condition, MT2 is positive with respect to the MT1, with gate is negative. In third condition, MT2 is negative with respect to the MT1, with gate is negative. And fourth condition, MT2 is negative with respect to the gate is positive. These are the four different types of modes of operation of triac. Yes. When MT2 is positive with respect to the MT1, with gate is positive. Yes. So here you can observe the biasing of triac. Yes. MT2 is positive with respect to the MT1, so the positive terminal of the battery is connected to the MT2 and the negative terminal of the battery is connected to the MT1, and gate is positive with respect to the MT1, so gate is positive with respect to the MT1. Yes. So here the positive of the battery is connected to the gate and negative terminal of the battery is connected to the MT1 terminal. Yes. In this case, what happens? That N2 layer becomes activated. So the P2 N2 junction becomes, what happens? P2 N2 junction becomes forward bias. Yes. The P2 N2 junction is in forward bias. So the charge carriers are moving into the charge carriers are moving into the N2 region. Yes, the charge carriers are moving from the P2 region to N2 region, which is mentioned in this diagram here. Yes, and here we are applying the positive potential at the MD2. So here P1N1 junction becomes forward bias due to the VMM or positive potential of MD2. Due to this positive potential of MD2, P1 layer will activated and P1N1 junction becomes forward bias and N1P2 becomes reverse bias. N1P2 becomes reverse bias. Yes. So the current flowing direction in this circuit is P1 N1 P2 N2. In this operation, the P1 N1 junction becomes forward bias. You can observe in this diagram, and P2 N2 is also in forward bias, but the N1 P2 junction is in reverse bias. But the N1 P2 junction is in reverse bias when we are supplying the positive gate voltage to the circuit. Yes, so when we are supplying the positive gate voltage to the circuit, it breaks the reverse bias junction, that means N1 P2 junction. So a breakdown will occur. The heavy current will flow in this track. Yes, so the direction of current in this circuit is P1 N1 P2 N2. This is the path of the current flowing in this track circuit. Clear? So it is like S here. Yes. In this case, we consider the MT2 is positive with respect to the MT1, with gate is positive with respect to the MT1. And second is positive with respect to the MT1, with the gate is negative with respect to the MT1. So in this, we are connecting the positive terminal of the batteries to the MT2 and negative terminal of the batteries connected to the MT1. Yes, and here the gate is negative, so the negative terminal of the battery is connected to the gate and positive terminal of the battery is connected to the MT1. Yes, so here negative terminal of the battery is connected to the gate, so N4 layer is activated. The charge carriers in the P2 will move into the N4 layer. Yes, so we can say P2 N4 junction becomes forward bias. Yes, and due to the positive potential at MT2, this P1 layer will be activated. P1 layer will be activated. The P1 N1 junction becomes forward bias and N1 P2 junction becomes reverse bias. Yes, and due to the N1 P2 reverse bias, this P2 N2 junction becomes forward bias. Again, the current flowing in this direction in this circuit will be P1 to N1, N1 to P2, P2 to N2. So the direction of the current is same as like first mode, but here the junction P2 N4 is forward biased and the current carriers are injected into the P2 layer. Yes. So here also current passing in the same path, even we are applying the negative gate. So that means we can say track is in the conduction by supplying the positive gate and negative gate. Yes, MT2 is negative with respect to the MT1, with a gate is negative with respect to the MT1. So here the negative terminal of the pad is connected to the MT2 and positive terminal of the pad is connected to the MT1. Yes, and the negative terminal of the pad is connected to the gate and positive terminal of the pad is connected to the MT1. So here we can say MT2 is more negative with respect to the MT1, along with the gate pulse is also negative with respect to the MT1. Yes. So when gate pulse is negative, so here the N4 layer will be activated. So that N4 junction is in forward bias. Yes, the charge carriers are moving from the P2 to N4 layer. Yes, P2 to N4 layer. Then what happens? So the charge carriers are moving from the P2 to N4 layer. Due to the negative potential of MT2, what happens? That N3 layer will be activated. That N3 layer will be activated, and N3P1 region becomes forward bias. N3P1 junction becomes forward bias, and then after P1 N1 junction becomes reverse bias, and this N1 P2 N3 P1 becomes forward bias, and P1 N1 becomes reverse bias, and N1 P2 becomes forward bias. Yes. So here the direction of the current flowing is from MT1 to MT2. It is from P2 N1 and P1 N3. This is the current flowing path in this circuit. Yes. So we can say track is operate in the negatively biased region also. Clear? And coming to the fourth condition, MT2 is negative with respect to the MT1, with a gate is positive with respect to the MT1. So when the terminal MT2 is negative, that means a negative terminal is connected to the MT2 and positive terminal is connected to the MT1, but the gate pulse is positive with respect to the MT1. So if the gate is triggered with a positive pulse, then what we can say? So N2P2 junction becomes forward bias. The charge is moving from P2 region to N2 region. Yes. So it is P2 and is in forward bias. Due to the negative potential of MT2, this N3 layer will be activated. This N3P1 becomes forward bias and P1 N1 becomes reverse bias. Then after N1 P2 junction becomes forward bias. Yes. So when when the terminal amplitude is negative and the gate is triggered with a positive pulse, junction P2 and 2 is forward bias and the current carriers are injected, hence the triac is in tonal mode. Yes. So these are the four different operating modes of triac. So simply you can say here we are having the two SES in the anti-parallel manner. When I are applying the forward bias and positive trigger, one SR will conduct, and same forward bias and negative gate pulse is supplied, another SR will conduct. So we can say For the positive and negative trigger pulses, this triac will connect. Yes, that's why we are saying this triac is bidirectional switch. Yes, so that's why we are calling this triac is a triode for AC switch. So the characteristics of triac is resembles like a ACR characteristics. Why? Because here it is triac consists the two ACRs in anti-parallel. Yes. So we can observe these triac characteristics in the quadrant 1 and 3. Yes. So quadrant 1 indicates the for the positive and quadrant 2 indicates the negative. So positive MT2 indicates the quadrant 1 and negative MT2 indicates the quadrant 3. Yes. So initially before the fault breakdown voltage, so we are having the minor current, so it indicates in the straight line in the first quadrant. After reaching the fault breakdown, then sudden current will increase, so then triac is in conduction. Yes. So first SCR is in conduction. Coming to the quadrant 3, so in second quadrant again before breakdown the small amount of current will flow in this SCR, it is leakage current. When it reaches to the breakdown voltage, again it starts the conduction. For the MT2 is negative. So we can observe the track characteristics in quadrant 1 and 3. These quadrant 1 and 3 resembles the mirror image of each one. Yes. So when MT2 is positive, it will present in the quadrant 1. MT2 is negative, it will present in the quadrant 3. Yes. So that's why I calling this one is a bidirectional. So the applications of triac is same as like SCR. These power electronic switches like SCR or triac or diac, these are always used to control the supply. Yes, that may be a lamp control or speed control of fans or AC motors or chopper circuits or AC phase controls. Yes, or we can use this track in liquid level control, temperature control, so any kind of controlling circuits. Yes, this is about the triac. Next we'll discuss about the diac. It is also one of the important power electronic device. Diac stands for diode for alternating current. It is also a switch. So this triac diac are advanced kind of diode, we can say. Yes, this triac diac both will work as a switch for alternating current AC supply. This triac is three terminal and which is controlled by gate, which is triggered by the gate. But coming to the DAC, we don't have the third terminal. It's named as gate. Here we are having only two terminals named as MT1 or MT2, or otherwise we can say anode 1 and anode 2. Yes, it is a three layer two terminal semiconductor device. It is also acts as a bidirectional because it can work for positive and negative cycles. Yes, but it does not have any control terminal, so it is a uncontrolled AC switch. Track is a controlled, SCR is also controlled. That means we are controlling the current flowing in the device by using the third terminal gate in the SCR and track. But coming to the DAC, we are having only two terminals. We don't have gate terminal, so it is not a controlled device. Yes, so it is a three terminal, two junctions semiconductor device. So here all the three layers have the same amount of doping, and it delivers symmetrical switching properties in both the polarities of the applied voltage. So we can observe the circuit symbol of diac here and the internal structure of diac in this slide. Yes. So we can discuss the operation of diac by considering when MT1 is positive and when MT2 is positive. Yes, when MT1 is positive with respect to the MT2, the second one is MT2 is positive with respect to the MT1. Two cases. Yes, so you can observe internal structure of diac N1 P1 N2 P2 N3 layers. Yes, initially we are considering the MT1 is positive with respect to the MT2. So that will be mentioned in this slide. So in this, when MT1 is positive, then what happens? This P1 layer will be activated. When MT1 is positive, the P1 layer will be activated. So that we can say that P1 and 2 junction becomes forward bias. Yes. So the negative terminal will be bias connected to the MT2 terminal. So in this N3 layer will becomes activated. So N3P2 junction becomes forward bias. The middle junction N2P2 becomes in reverse bias. So the conduction takes place in this device in the path of P1 and 2, P2 and 3. Yes. So it will mention in this diagram also. Next second case, when we consider the MT2 is positive with respect to the MT1. So when MT2 is positive with respect to the MT1, the positive of the band is connected to the MT1, the negative of the band is connected to the MT1. Yes, positive is connected to the MT2 and negative is connected to the MT1. So when positive of the band is connected to the MT2, that P2 layer will be activated. So P2 and 2 junction is in forward bias. The neutral of the battery is connected to the MT1. So N1 layer will be activated. N1P2 N1P1 junction is in forward bias. Middle junction P1 and 2 is in reverse bias. The current conduction takes place here. So it is in the direction of P2 and 2 P1 and 1 path. Yes. So you can say the conduction will be possible in both the directions. So it is a bidirection, but it is an uncontrolled switch. So we can observe the wave characteristics of diac in this slide. So one is for the positive off cycle and second one is negative off cycle. Yes, conduction state for the positive off cycle, conduction state for the negative off cycle. It is also like a S here, but it is a uncontrolled. Here we are not supplying the gate paths. So here we are not mentioning the IC current. Yes, before the breakdown voltage, it is very small. It is a reverse current, and when it reaches to the breakdown voltage, sudden current will flow in this circuit. So it is for the positive off cycle. Similarly, negative off cycle. You can observe the characteristics of diode. So the applications of diode, it is also a switch. So we can use this diode for the controlling of any AC mechanism. I say lamp controlling or fan speed controlling or AC motor controlling or temperature controlling or liquid control, anything. And here diag can be used as a to trigger the triac circuit. Why? Because the triac circuit requires the triggered pulse from the gate terminal. So that can be provided by the diac circuit. Yes. So this diac can be used as a trigger device to the triac circuit. This is about the diac. Yes. Thank you.